First example in lesson 5.6 is on the SAS case and finding all the missing sides and angles for a triangle that's given to us with SAS. So just starting out, we need to recognize that it is SAS by labeling with the information that we have here. Here's our general triangle we've been working with since last section, but we have little a, little b, and big C, 95. So as you can see now, if we go in order, this is SAS. Just remembering back to geometry and how we determined which of the acronyms it was. Now, just one thing to keep in mind about this lesson in comparison to 5.5 is that with the law of sines, we did ASA, AAS, and SSA. For law of cosines, we're going to be working with SSS and SAS. So this is the example of SAS. The SSS will come next. What we're going to do here is just start by picking the appropriate version of the law of sines. And for this first one, since we have big C, we're going to use this one right here. That'll help us find whatever is missing in this case. Now, the only one we don't have from this third version, it looks like, is little c squared. So that's going to be our unknown. Put that over here. And then we want to go a squared plus b squared to start. So that's 12 squared plus 21 squared. Then minus 2 times a times b. And then times the cosine of c, 95. Now, all the numbers are on the right-hand side, so we really can just punch this all into the calculator and see what it comes up with. In this case, c squared would end up being about 628.93. If you square root that, c then is about 25.1. We don't need to worry about pluses and minuses because with working with these triangles, we're always going to have positive quantities. So that's going to be part one. I found little c, so that's 25.1. That's good. Now we're just left to find angles A and B. Now the temptation here is to want to go back to law of sines because we do have enough information for that, but I'm going to strongly encourage against that because in some weird cases, if you use law of sines for the second step, it doesn't work out very nice. So I would really recommend that you don't do that. You just do one more step of law of cosines. It's always going to work out if you do law of cosines. So in the second step, we just got to choose which one we want. Let's maybe find angle A, just because. And so we'll pick this first version of it because that involves an A right there. I'm going to plug in what I know. I have all the little numbers at this point. So A squared is, so that's 12 squared on the left-hand side, then b squared plus c squared. So we've got 21 squared plus 25.1 squared. Then we're going to minus 2 times b times c, and then times cosine of A. We don't have A yet in this one. That's what we're trying to find. One thing that I would recommend you doing is thinking about the order of operations. Order of operations is really important here because a lot of people like to take all of these numbers and just sort of push them all together. But remember that multiplication becomes first in order of operations, so we can't do that. We can put these two numbers together. If we do that, those two numbers, and then we subtract from that side. So we're going to take these, just add them together, and subtract them over to the other side. What we'll end up with, just taking out some of the little details, we're going to end up having negative 927.01 on the left-hand side. If we just take all of this, subtract it from 12 squared. And then over here, if I multiply all those numbers together, that gives me about negative 1054.2. I still have cosine A right there. So we got to rearrange this correctly first. That's an important part of that step. Then, if we divide by 1054.2, the negative, over to this side, what will end up happening is that we're going to be left with cosine of A, and that will be approximately 8.793. You can verify on your own if you like and come back if you need to. But we then, once we have cosine A equals that, then we do inverse cosine of 0.8793. Remember to make your calculator in degree mode again. What's going to end up happening is that A is going to be about 28.4 degrees. Now, because again triangles add up to 180, we can just take 180 minus 95 minus 28.4 and get our last angle, which is big B. That's the easy part, and that's about 56.6. So now we have the three missing pieces, and we use law of cosines on an SAS triangle.